All right, we're back with another LeetCode challenge. This is called Search 2D Matrix 1, very similar to the last problem I did. I'm hoping it's going to be, well, I'm guessing it's fairly similar, just with made some slightly different requirements. But yeah, let's get into it. Let me start a timer, give myself, let's give 40 minutes. Hoping to be able to complete it and have an efficient solution before then, but yeah, we've got our timer right here. Let's get started. So we need to write an efficient algorithm that searches for a value target in an m by n integer matrix. Okay, so it's like the exact same wording. This matrix has the following properties. Integers in each row are sorted from left to right. Okay. The first integer of each row is greater than the last integer of the previous row. Okay. This is just kind of, it's very vague. Sorted in what way? I guess we'll find that out. Look at the test cases. Okay, so let's just, I'm gonna break this down. Yeah, so this is our input, right? So matrix is this. Let's just look here. Okay, so there's 4 elements, 3, or I guess there's four elements in each row, 3 rows in the total array. And the output here is true. So we're searching for target. Okay, so same verbiage. Looking for target, and in the integer matrix, the matrix has the following properties. In each row, they're sorted from left to right. So I guess an assumption we can make here is that when they say left to right, the integer values are sorted in ascending order from left to right. So I'll just make that really explicit in my explicit rules here. Integers in each row are sorted from left to right in ascending order. Okay, and the other property of the matrix, the first integer of each row is greater than the last integer of the previous row. Okay, I'll just copy that down. All right, so we've got that. Okay, so let's see. The first integer of each row is greater than, I'm gonna make this smaller, the last integer of the previous row. Okay, so previous here just being the one that was encountered earlier in the, I guess, traversal of elements here. So if we're looking at like this one, right, this is prior to this element. This is the element at index 0 of matrix. This is the element of index 1. So there's that previous relationship. So we've got target here, and the return value from our function is true. So we find that 3. So, okay, and it needs to be an efficient algorithm, so no nested loops or anything. We just want to, okay, so let's think about this. If I like, I'm going to, yeah, I'm gonna, I'm guessing this is the same, 1, 2, 3, 5, 7, 10, 11, yeah, it's the same. Okay, so I'll just remove this portion, just do matrix, target is 13, and then the output is false. So it didn't find 13 here. Okay, so basically, I think, okay, I think this is like the very, very similar. So what are some, I guess, like, what is a pattern that makes sense to implement for this? So if we're looking for 3, do we want to start, seems like we would want to start at either of these corners, right? So if we're thinking about this as like a box, let's actually, I'm gonna grab that and I'll just drop it down here. So we're just gonna call it our matrix, and let's just log it out first. Matrix, okay. And if we were to run our code, so node search 2D JS. Okay, so this is what our matrix actually looks like. I prefer this visual to the alternative. But our target here for the first test case they provide is 3. So does it make sense to I guess, start iterating. Okay, so if we, all right, so I think, okay, so if we're here and we're starting on the top left corner of our matrix, we want to see, okay, is the current element less than or equal to, or is it greater than or equal to the current element? Because this will be the minimum number, right? And okay, so we would be starting there, and then we would check. Okay, so 3 is greater than 1, so we would want to move to the right. So increment whichever, I guess, counter or index value would get us in that direction. So moving to the right. So we want to be looking, want to be inspecting this element. And so essentially what's going on here, this is just it's like essentially a bunch of sorted elements that are just separated into their own individual arrays. But all of these elements will always be less than the first element, right? So the largest element, so there's some things that we can really assume here just based on the problem, very much explicitly stating that all elements in earlier or previous rows, so this is some subarray, all of these elements must be less than the first element in the next row, right? So all of these will always be less than 10. So yeah, that's where we're at with that. So if we're thinking about this, how do we want to approach it? Because it kind of just seems like we would want to, I think it would make sense if we just checked. So like, I think we would just want to look, okay, is the element between these two numbers? So like first and last, I guess. And then if it is, then that number, if it exists, would have to exist in that row. I'm gonna let my dog in real quick. Okay, so if we have those two values, first and last, so the first element in the row and the last element in the row, and the number isn't in that range, then we can just discard that entire row because we don't really care about it. And if it does exist in that row, in the case of this first example with target 3, then we just want to simply just look at this row, and that's the only place that value could possibly be. Okay, and I guess in the case where we're looking for the 13, it wouldn't be in this range, right, between 1 and 7. It would have to be in this middle row between 10 and 20 because it is greater than 10 and less than 20. So yeah, we would just be only looking in this specific row. So I think that gives us a pretty clear understanding of how we want to approach the problem. I'm just going to start thinking about some of the steps we're going to take. So if we're here, and I guess we can just kind of be a little more explicit with exactly what's happening here. So our input is I guess potentially it could be an empty array of arrays, right? So it could look something like this maybe. Technically that is kind of a matrix, not a very helpful matrix. So I guess perhaps we want to guard against that, but I guess just it would be a matrix, right? So matrix, which is just an array of subarrays. And okay, so that's our input, and our output is always going to be some Boolean value. So does the target exist? So target integer, array of subarrays containing integers. Okay, so then we have some target integer, and we want to return some Boolean value. So just going to return to the problem statement, make sure we didn't miss anything. Each row is sorted from left to right. The first integer of each row is greater than the last integer of the previous row. So this is really where we're getting a hint of how our algorithm should work. So Yeah, okay, so we want the first and last of some row, right? And we want to, okay, so we need some values, right? So we want to essentially, I guess, first like guard for an empty 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 matrix. So that was just this, something like that. Does it break our how we're thinking about this if it just has like something like 1 and like 2? If there's just one element in each subarray, so there's just 2 rows and one single column. If we're going to represent it like how it would look, it would be something like this. Does that make sense to guard for? I think it does. Yeah, I think it does. Because at that point, I think we would just want to flatten it and then just check if it includes it. Because I don't know. I guess if it's of, I guess if this thing is of length 1, then we would just want to iterate through it. So that's still O of n. So yeah, okay, that makes sense. So guard for empty matrix, and then we also maybe guard for single column or row matrix. So that's like, so this is the single column. And then what about if it was a single row? It would just be like 1, 2, 3 or something. And for either of those cases, we would want to just traverse either the column or the row. So I think that makes sense how I'm thinking about that. Let's think about this. Okay, so have that. I'm gonna move this stuff just up here, just a little bit more out of the way. And my dog is really whining. Okay, so let's think. What's the next step here? I think we want to start iteration. And so I think maybe just like loop over rows, starting at row 1. And then for each row, we essentially want each row we want the following. And so we want the first element and last element. I guess just first and last elements. And so these are going to be like first, last. This is going to be represented as like a range or something, or we're going to use it as a range. And then just check. So I guess like check if the target lies in between the first and last. Okay. So if it lies between the first and last, then we just want that range, right? So if between first, last, then we want to search that row only. And if it is not between those, so if not, then we want to continue to next row, because we know that it's not within that range of values, or it couldn't possibly be. And okay, so now we're thinking, so we want to search that row only. So basically just like if current row, and this is the only time we're ever going to be iterating through it. So it's not quadratic time. Okay, so if current row is, if current row contains target, then just return true. Return true. Otherwise, we can just continue. And if we get to the very end, so we've looped through everything, we haven't found it, then we can just return false. Okay, feel good about this algorithm. I'm gonna walk through it. Like, let's say we walk through it for a case where it's like 34 or something, right? So it's not an empty matrix. It's not a matrix that has a single column or a single row. So neither of these guard clauses are evaluated, or neither of the statements after the conditional logic for those guard clauses are evaluated. So then we move on to our core algorithm here. I want to loop over rows starting at row 1. Starting at, I guess, row 1, which is matrix at index equals 0. So this tells me I'm probably going to be using a for loop here, just a standard for loop. So we're looking here and we're checking, okay, what is the first value and what is the last value? So that is our range, so 1 through 7. And remember, we're looking for 34. I'll just write that out. Const target 34. So we're looking for that, and it's not in that range. So we just want to continue to the next row, right? So now we're not looking at this row anymore. We've discarded all of those possible values. Now we're looking between the 10 and the 20. And again, it doesn't lie within that range, so we can once again discard that row. And now we're on to the last row, and we're gonna see, okay, the first element is 23, or I guess the minimum is 23 and the maximum is 60. So, okay, yes, 34 could potentially exist in this row because it exists between those two minimum maximum values for our range. So we would just essentially take this and check to see, check if this row includes our target. And I think we can just use like some sort of short circuiting thing there. There's a couple of ways you could do it in JavaScript without getting too fancy or anything. So yeah, that works for that case. Let's think about it for one of these, right? So okay, and we've got how much time? 23 minutes. Okay. So we're thinking about this, and we're looking at that test case, right? So maybe we'll just do like const. I'm not sure what we want to call it just yet. Just column or single column matrix. Okay, and then we can just get another one, but for a single row. Single row matrix, single column matrix, and this one was just simply the 1, 2, 3. Okay, something like that. So let's just think about, like, we can remove that one. So if we're thinking about this one, right, we would need to check to see if, so I guess we should write the guard clause logic there. So if the first element is of length 1, and so then we know immediately that it is a single column matrix. Or if the entire matrix's length is 1, then we know that. And so for either of those, we would essentially just loop through the column or loop through the element at the 0th index. Okay, so I think that makes sense. I don't know if I want to express that with pseudocode right now. I might just jump into the core algorithm and see how it goes. So what are we calling this? Which is like search matrix. I think that's what this is called. So const search matrix and target. Okay, oops. Matrix target. Okay, got that, and it's gonna comment this stuff out for a second. And let's declare our target as well. Const target, and let's just go for like 16 or something. 16 initially. So we're going to try to evaluate this so the output should be true. Okay, and then we will just write our function invocation down here. Search matrix with matrix and target. Okay, and that should be true. Okay, so let's get into it. So I'm gonna write the guard clauses once we've solved for the core algorithm. So we've identified them. I think that's enough for now. So we confer with our algorithm here. We essentially want to loop over rows starting at row 1. So we're just going to use a standard for loop for index matrix, and then this is going to be a row, right? So we have our looping construct here, and I just want to ensure that everything is working exactly how we expect. So here we're expecting to see each individual subarray just printed out to the console when I execute this code. So node, and that's exactly what we see. So that's working just fine. Always good to test your code. Maybe not in interviews, but always good practice to test your code if you're unsure exactly what's going on, or just want to ensure that you're not gaslighting yourself if you can't understand what's going on with your code. But anyway, let's check. Okay, so for each row, really, do we? Yeah. So I guess we take the row, right, and we want maybe like const min would just be row at index 0. So again, when we're looking at this matrix, we're evaluating this row, and we just want this value and this value. So just the minimum and the maximum. So that's what we're grabbing here. So minimum, so I guess row, let's call it row minimum. And we'll call this row maximum row, and it'll just be, we might be able to just use, I think we can, yeah, let's just use this value and just calculate it once. So it's called lang is that. Okay, so we want length minus 1. Okay, and let's just take a look and see what we're getting here again. So we're just going to log out what we want. Our calculator, I guess, retrieving with these operations. So row min, or row min and row max. Okay, let's just see what we're getting here. And so we see 1 and 5, 10 and 16, and okay, so that is not correct. We should not have, let's see, where is this going wrong? I think it's just off by 1. Yeah, okay, so now we're seeing the 1, 7, 10, and 20, which if we look back here, we're seeing that value. So we had just, we'd excluded, or we hadn't gotten the last value, we got the second to last value. So yeah, always important to check your code if you're making little mistakes like I just did. So okay, so we have our range, I guess, like min max, right? So we essentially just want to check to see if the target lies between the first and last range. So if target is greater than or equal to, or if target is greater than or equal to the row min, and so if it's greater than or equal to the row max, or why did it? Okay, so if it's greater than or equal to row min, and target is less than or equal to row max, then we know that this is the row we want to look inside to try to see if the target exists there. So what we want to do here, so if it's between first and last, then we just want to search that row only. So essentially we're just checking row, right? So does row include the target? And if we can find it in that specific row, then we're just going to exit out of our for loop with this return statement and return the value that is returned by this method invocation here. So I might add a comment here. Well, this is just essentially found. So this is if the element exists, or if the target can be found in the current row, yeah, that's essentially what we're expressing here. So if the target can be found in any row, it is this row. And then in the case where it is not within the range of the row min and row max, then we simply wanted to continue to the next row, right? So we can just do absolutely nothing. And yeah, let's take a look and see where we're at. And we'll just return false otherwise. And so the reason why I have that is because what if the target isn't in any of the rows? We would have essentially traversed the entire, we would have checked all the different ranges, right? And we would have seen that, okay, it's not in any of these ranges. So let's say, for example, that it was like 100 or something. That's obviously not in this matrix. And if we hadn't have, if like say if we comment this line out, we would expect to just see undefined instead of false, right? So let's just verify that here. If we node search, we're seeing undefined, right? And that's because if we, like, let's say we want to log whatever the current I is, the value of the current I, we're going to see, okay, it looped through all three, or so to the entire matrix, and it didn't find it anywhere. And so it then exited our for loop, and there was nothing left for it to do. And so this function implicitly returned undefined, because that is what JavaScript functions do if there's not an explicit return statement evaluated. So we actually want this here just to ensure that that works. So now if we run our code again, we're going to see false. It is not in this matrix, which is what we were hoping for. Given that, you know, this 100 is not within any of these ranges. So yeah, let's check and see. Let's go const target. What about like 2 or something? We're going to see that it is not there because it was not within this initial range, and then it immediately exited. Great, so that's working. Let's just make sure that it's working for a given test case, and it is. So 3 is found, and we only evaluate this first row. Great. Okay, and then what was the other given example? I think it was 13, right? Yeah, 13. Okay, so we can also test that one as well. And we see that it is, yes, it is false. So I believe this is fairly efficient. I guess I should probably, I think I'm going to finish writing the guard clause work. So I'm just going to comment this stuff out, and we'll just start taking a look at these ones just so that we have better coverage before we take it over to LeetCode to see how we did as far as our algorithm goes. So we want to guard for the empty matrix, right? So we need to check. So I guess I think the empty matrix, we first have to check to see if both the input matrix and the first element in the input matrix, if they're both, or if the matrix's length is of length 1 and the first element, so that first row is of length 0, then we know that there's going to be nothing except for a single empty array inside the larger matrix array. So the case of, like, where did I write that? Something like this, right? This is a test case where, okay, the length of the input array is 1, and the length of the first element subarray is 0, and so that just means that we have an empty array. So we're going to express that up here. So we'll just get started on that. So we're going to check for empty matrix. And so what we're going to do here is just if the matrix dot length is equal to 1 and matrix, the first element, so that first subarray length, is equal to 0, then we know that this is an empty array. Or I'm sorry, it's an empty matrix. And so we can just return that error message. So now we need to check to see if the matrix length is equal to 1. So we're thinking that, so this is the case where this is the single row matrix because the length of this input array is just of length 1. And this part was not evaluated because this specific test case has a length of 3. Then we want to essentially just check to see if the if matrix at 0, so the first element in our input array of arrays, we need to essentially just check to see if that includes our target. And we can simply have a early return statement there. And let's check that right now. If we just, so we're looking at the single row matrix here, console log search matrix, and we're going to use single row matrix, and we'll just say our target is 2. Okay, so if we run that, we should see true, which we do. What about if we run our code again and give it a different target? We should see false. Okay, so we know that this test case is handled, so I'm going to comment that out, and we now want to deal with this test case, so the length, the circumstance of the single column matrix. So we can actually, we'll close that up. So I guess I should, so this is checking for an empty matrix. This is checking, check for single row matrix. And then the final guard clause we're going to have here is check for single column matrix. And so to do that, we essentially need to check to see, okay, is the matrix length or the matrix 0 length? So again, we're thinking, we're thinking okay, so it's actually, this is matrix, I think I might have, did I flip it? If matrix at index 0 is length 1, did I mess this up? Let me think about this for a second. So we're thinking, so for this specific situation, we're looking at the length of the first element. And so for that one, it was this test case. So we're thinking about that. If this is of length 1, which it is not, then, so maybe we don't even need to be concerned with, I actually don't think that this guard clause is being evaluated. Let's just check and see. Here, okay, and then let's uncomment this again, and we'll do search matrix, single row matrix. Okay. So that is, oh, and it's because of the 4. Okay, so we do like 2. We should see true. And it's not actually evaluating this guard clause. So our core algorithm actually works. That might mean that it actually works for both the single element, the single row or the single column situation. So I'm actually going to comment this stuff out for a second, and let's just see how it runs with this test case here. So we just checked this one and it passed flying colors. We can try this one now. I think this case doesn't work, or maybe it does. Okay, well, there's only one way to find out, I guess. Single column matrix, and let's look for that too. And maybe we give it like a couple more, 4, and then like 8 or something. Okay, so we're using single column matrix, giving a target of 2, so maybe give a target of 4. We should expect to see, we expected to see true, but instead it was false. So that shows that this portion of the algorithm is not working. So we've got about 5 minutes left. I think that's still plenty of time to sort this out. I think I just need to check. I think I just need to write a guard clause for this specific test case. So call for single column matrix. So if matrix at index 0, so the first element is of length 1, then we know that it is a single column matrix, and now we just want to return I think I'm just going to use a normal for loop here. So what do I actually want to do? I want to look at all of the elements in the 0th index in our matrix. So for each element, okay, so we need to traverse matrix. Matrix dot includes so if any of the, I'm thinking I could just flatten it here. That would then I would not have to worry about it actually. So maybe that, I mean, I suppose I could do it that way. If we just like matrix flat and then check to see includes target. I think that would work, because then it would just flatten it into a single array that is of depth 1 instead of depth 2. So if we were to run, it's still false. Okay. Single column matrix for, okay. Let's log and see what we're actually getting here if we just do, oh, okay, it's just never being evaluated because I just typed that wrong. So now it's true. Okay, so I want to say we're done. Let's go over to LeetCode and take a look and see how we did with their tests. If my computer will let me. Okay, and I think I gotta, yeah, move this over. Okay, so now we're over on LeetCode, and let's just check to see how it goes. Okay, so it's passing those test cases, which is what we kind of built our solution off of. And see how it does with the other test cases. Wrong answer. Okay, so the input was 5, and it was expected to be true. Wonder why that would be. So it's 1, 3, 5. Okay. Well, I guess we didn't pass for LeetCode. That would this would be qualifying as a fail. We're just about out of time. I wonder, I guess I could try to sort this out. So it's 1, 3, 5. So that in our code would be evaluating. So 1, 3, 5. Okay, let's actually go back and test here. So we just do like array and then 1, 3, 1, 3. Oh goodness. 1, 3, 5. And then we're looking for what was the target? 5. Okay. That's 6. Okay. So for running, we're getting false. So this should, maybe we do need that other guard clause. So if matrix is of length 1, I think I might have just gotten them flipped around. If matrix is of length 1, then that means that there's only one row. Okay. So then we just want to check that for that current row if it includes our target. Okay, so if we are to run this, we should see that it is finding that target. Okay, and it is. So I'm going to plug this code back into LeetCode, and let's hope that it actually pass. It'd be kind of frustrating if this video all led up to a fail. Let's just take a look, see how we did. Okay. 1 in 1. So we didn't think about, wait, it's expected to be true. Okay, there's just something deeply wrong with my solution, I guess. Wonder, so it's 1, 2, 1, 2. So our target, I feel like it should have, so if target is greater than or equal to minimum row, and target is less than or equal to row max, this should have been evaluated for that specific row. So for like the first one, it should have evaluated that first situation. I wonder, so it's getting to the second row. Why is it getting to the second row? It should short circuit the first row. It should short circuit after the first row because that's where 1 is. And so row matrix there. Okay. And then row minimum would be the first element. Row maximum is the last element, which we verified what that was. So then if target, so I guess maybe just log out target. Well, no, log out row min and row max. Just to make sure I'm not going crazy here. So it was 1, 1, and then 2, 2, and we're searching for 1. Okay, so undefined is being logged out. So what is the index? Is this just an index thing? So row minimum is working, but not row maximum. So what is the index? So row max is just never, it's just undefined. And so length is matrix length. Oh, okay. So it comes down to this, because for this, the matrix, well, but it would be the same, right? Because it's, so length would be 2 here. So then 2, okay, so then I guess that needs to be 1 actually for row max. I wonder why that didn't work beforehand. Like we got the error, remember when we were writing our for loop? Okay, well, we're just wrong. I wonder, yeah, okay, I'm gonna go back. Maybe I can throw the actual solution that I come up with. But we would have failed this interview. So yeah, I hope you had a good time, learned something, maybe picked up something that I did wrong that you will now avoid. But anyway, thanks for watching.